Quantum computing. 3 major barriers to mainstream adoption. Imagine a world where computers can solve complex problems that have plagued humanity for centuries, from curing diseases to combating climate change. This is the promise of quantum computing, a revolutionary technology that has the potential to supercharge our computing power and transform industries. But here's the shocking truth. Despite its vast potential, quantum computing is still far from being mainstream, and there are 3 major barriers that must be overcome before it can change the world. So, what's holding us back? Let's dive into the fascinating world of quantum computing and explore the challenges that lie ahead. Quantum computing has the potential to accelerate innovation in various fields, including drug discovery, logistics, artificial intelligence, and more. For instance, it can help us simulate complex molecular interactions, leading to breakthroughs in medicine and material science. However, the fact remains that quantum computing is still in its infancy, and several significant hurdles need to be overcome before it can be widely adopted. One of the most significant challenges is the technical aspect of processing qubits, the fundamental units of quantum computing. Qubits are incredibly fragile and can exist in thousands of states simultaneously, making them prone to errors caused by heat, vibration, or electromagnetic fields. To mitigate this, scientists use cutting-edge technology, such as supercooling qubits to near absolute zero and housing them in vacuum chambers. But even with these advancements, the number of qubits required for practical applications is staggering, with estimates ranging from 10,000 to over 13 million. And then there's the issue of software availability. Most existing quantum software is tailored for specific purposes, leaving businesses to develop their own tools and infrastructure if they want to harness the power of quantum computing. But here's where it gets even more complicated. Beyond the technical challenges, there are societal and cultural obstacles that must be addressed. For example, there's a significant skills gap in the quantum computing industry, with far more job openings than qualified applicants. This could lead to a brain drain where top talent is snapped up by large corporations, leaving smaller businesses and startups struggling to compete. Moreover, the high cost and complexity of quantum computing infrastructure could exacerbate technological inequality, making it difficult for smaller organizations to access the benefits of this technology. And this is the part most people miss. The security implications of quantum computing are enormous. With the potential to break current encryption methods, quantum computers could compromise sensitive information and threaten global security. So, what's the solution? Some experts believe that artificial intelligence, AI, could be the key to unlocking the full potential of quantum computing. By leveraging AI algorithms and machine learning techniques, scientists can optimize quantum computing processes, such as stabilizing qubits and improving computational power. In turn, quantum computing can accelerate AI research and development, enabling faster training of models and more efficient processing of complex data. But for businesses looking to capitalize on the quantum revolution, the focus should shift from solely technical challenges to addressing the societal and cultural barriers. By investing in education and training programs, cultural development of education can respective supporting the innovation technology, organizations can help create a more inclusive and equitable quantum computing ecosystem. So, will we see a future where quantum computing transforms industries and solves some of humanity's most pressing problems? The answer lies in our ability to overcome the technical, societal, and cultural challenges that stand in our way. As we move forward, it's essential to ask, what role will you play in shaping the future of quantum computing? Will you be a pioneer, a skeptic, or a bystander? The choice is yours, and the conversation starts now. Unlocking the future. Commercial quantum computing explained. Quantum computing is on the brink of revolutionizing industries like never before, with its commercial potential rapidly moving from theory to reality. Experts predict the quantum hardware market could exceed an astonishing $21 billion by the year 2046. This surge in interest isn't happening in isolation. Governments worldwide, alongside tech giants, are strategically positioning themselves to benefit from the arrival of quantum machines that promise to solve complex problems in high-performance computing, HPC, pharmaceuticals, chemistry, automotive manufacturing, and many other sectors. But here's where it gets controversial. While the buzz around quantum computing is enormous, how close are we truly to harnessing this technology for real-world commercial breakthroughs? That's exactly what ID TechX technology analyst Noah Elalamy addresses in an insightful webinar that unpacks the essentials of the quantum computing market. He explores the unique value quantum computers offer, especially when intersecting with artificial intelligence and cloud platforms, two fields already transforming the technology landscape. The webinar sheds light on critical questions including, what fundamental benefits do quantum computers bring to industries? Which technologies and methods are top contenders for building successful quantum computers? How are leading cloud providers, Microsoft, Google, and AWS, approaching their quantum strategies? Do quantum computing and AI stand in competition, or could they actually complement one another? Finally, just how near are we to achieving tangible commercial outcomes from quantum computing? For those eager to dive deeper, this discussion is based on findings from the comprehensive report Quantum Computing Market 2026 to 2046, Technology, Trends, Players, Forecasts. Available at https://www.obiquantumcomputing.com/research-report Quantum Computing Market 1110. The report offers profiles of the pioneering companies driving innovations, thorough technical analyses, and long-term forecasts covering 8 different quantum hardware approaches. These include superconducting qubits, trapped ions, neutral atoms, photonics, silicon spin qubits, diamond defects, topological qubits, and quantum annealers. And this is the part most people miss. Each hardware technology brings unique strengths and challenges, influencing which industries might benefit first or deepest from quantum advances. Given the considerable diversity in technological approaches, it's worth asking, can the market support so many competing quantum architectures? Or will one clearly emerge as dominant? Moreover, with deep-pocketed hyperscalers investing heavily in quantum, are we witnessing a collaboration that will accelerate progress, or a race that risks fragmenting the ecosystem? What do you think? Are we on the cusp of a quantum revolution that will reshape industries in the next 2 decades? Or are we overestimating quantum computing's practical readiness? Join the conversation and share your thoughts below. The real path to quantum advantage. IBM and Pasqal's new framework explained. Quantum Leap. Researchers chart a measured path to quantum advantage. A groundbreaking study from IBM and Pasqal has proposed a rigorous, criteria-based framework for defining and demonstrating quantum advantage. The framework emphasizes the importance of verifiable outputs and measurable improvements over classical computing methods. The study identifies 3 key problem types: sampling, variational algorithms, and expectation value calculations as the most promising avenues for achieving near-term quantum advantage. The research underscores that progress in quantum computing depends more on effective error management than algorithm design. Hybrid quantum classical systems and hardware platforms like superconducting circuits and neutral atoms are highlighted as crucial enablers of quantum advantage. The study strikes a balance between hype and skepticism, recognizing the potential of quantum computing without dismissing the challenges that lie ahead. It provides a practical roadmap for achieving quantum advantage, emphasizing the need for clear, testable benchmarks and framing any claims of quantum advantage as falsifiable hypotheses. The researchers predict that credible evidence of quantum advantage is likely to emerge within the next 2 years, enabled by sustained coordination between the high-performance computing and quantum computing communities. This measured approach to quantum advantage is a significant step forward in the development of this groundbreaking technology.